any issue related to your research, in the research at the international arena, and what could be the new avenues of the research. Like that, I mentioned few things, formation of the groups, etc. Let me speak one thing, and then I will open the session right now. And with you, Professor Brende and Veeramani, both are there. Me also present for the same. We have planned, yesterday we have discussed, me, Professor Brende and Veeramani. We are planning to edit a book of this 5 days GAN program, and we welcome the articles on mythical fixed point theory and applications for that edited book, and most probably we consult Springer to publish the book. That is what we have decided yesterday, and we will check out that. Already checked out. I will plan, and after a thorough discussion with our experts, we will consult the publication agency, and once we get through, we notify all the participants, your supervisors, and other experts of the worldwide fixed point theorists. That is what we have planned. And if in this case, if the book comes out as a output of the GAN, you are also benefited, as well as the funding agency also feel very happy that their outcome is excellent. The feedback forms are also given, or going to give, each one of you 5 forms. You have attended all the 5 experts lectures. Yesterday, one lecture. Every day, Professor Brende and Professor Veeramani's lecture. So please give your feedback, your, I can say, the opinion. There are few pages, a few pockets are there where you need to write. Please do write whatever you felt over here, going to feel for all the 5 days. Tomorrow is the validatory at 3 p.m. and there are many who are leaving this station even before 3. So far it is difficult for us to conduct before 3, because once the validity is over, so very difficult to stop the participants to attend the lectures. Professor Birende is also leaving tomorrow at 9 o'clock. His flight is 8 something. So he has to leave. Positively, he has to leave by 4:30 or 4 o'clock. So that's why. So once within half an hour, 40 minutes, this validity is over, and as soon as this is over, he will leave this place. And so with this, I shall take leave for this time, and please you present your queries, your problems, your research problems regarding anything, any problem you can ask. So one of you, I think, yeah, Apka, please take a mic. A mic is there. Please take a mic, and whomsoever wants to, I think it is there or here. Yeah, please. So those who are interested, they can ask. To Manjusha.
Sir, you have explained multi-valued and set-valued functions, but even though I have slight confusion, I understand that for set-valued function, graphically we get spiral kind of graph, whereas it is not true with multi-valued. But how mathematically we can distinguish both? Because in some books it has mentioned that both are same.
Then it's okay. In fact,
both are same.
I do not know about so multi-valued map is symbol. Given an element in the domain, the image is a non-empty subset of a codomain.
Yeah.
It is just a subset. So that's it. In one natural way, for each x, the set of nearest point in general is a set value. X, the image is, A is just a compact set. X goes to, no, you can, yeah, you can see it also, no problem. See, this you have seen, X, no, please see it. I will write on the top. XD metric space, A non-empty compact set.
Yeah.
So then, for each x in the domain, the nearest point, consider those elements in the set A, which is nearest
to
closer
the-
to x, such that distance between the point x and the set A equal to distance between xy. For example, compact means the function y goes to distance between y comma A, continuous. Continuous function on a compact set attains its maximum and minimum. So here we have to say here, so this is, we know that infimum of distance
Yeah.
between x and small a.
Yeah.
So then in general it is a set valued map. And we pointed out, suppose A is a non-empty, closed, convex subset of a Hilbert space,
Okay.
then for each x, the nearest point is unique.
Unique. Okay.
And further, this maybe we will discuss tomorrow, it is non-expansive. Norm of, because this single one element, image, it is like f of x. P suffix a of y less than or equal to norm x minus y. In fact, this, what is enough is, A is a closed convex set,
Yeah.
then for each x in the domain, P suffix a of x is non-empty.
Yes.
Nearest point will exist. What is called strictly convex we discussed, that will give uniqueness. Single,
Okay.
But in general, it's a multivalued map.
Okay.
That's why it can be any set.
Okay.
Image of, let's say if we say even from R to R, image of x can be a set. Okay, when you are telling say x plus 1, x plus 2, like that. Image of x is a set, that's all.
Okay.
Then we have used what is upper semi-continuous. I mean, that case, for a set-valued map, when that is continuous in some, we have discussed what is Kakutani fixed point theorem.
Yeah. Yeah.
K, compact, convex subset,
Convex subset.
T from K. Image of each element is a closed convex subset.
Okay.
Then that map is upper semi-continuous,
Yes.
if and only if inverse image of, you can tell anyone. Upper semi-continuous, if and only if inverse image of closed set is
Closed.
closed. In particular, if A is compact or approximately compact, the metric projection, P suffix A also upper semi-continuous. It is just image of X is a set. X belongs to the image Tx, then that case multivalued.
Okay.
Multivalued map as a fixed point means essentially distance between X and the image. Image is a closed set. Distance between X and Tx equal to 0.
Okay.
Distance between a point X and a set is 0 means what? X belongs to the closer. But closer is a closed set already, that means X belongs to Tx.
Okay.
I don't know, I'm not familiar with the other type of spiral or graph related to set valued. I mean, I don't think any graphical representation is there for. Selection is there.
Okay.
Under what condition? Such multivalued map as a selection. For each x, some small f element, small fx belongs to Tx, and that f is under some condition it is continuous. Like that, then single valued map we can convert.
Okay. Fine.
Yeah. I don't know whether you are satisfied or.
Yes, sir. Satisfied.
Thank you. Any other? Same topic, anything else? Okay.
Okay, sorry. I'll say. So the idea is that there are a lot of mathematical objects, we cannot figure them, we cannot represent them geometrically. It's ideal to have such situation when we can represent. Coming back to this, how to graph multi-valued map, this is not possible, at least. So.
Particular, if you come to R to R, then if it is a selection.
Okay, so just a selection we can represent. But I just want to say how you work in four-dimensional space. We cannot represent, we are in a three-dimensional space. We are living in this and we cannot represent or draw a mathematical object in fourth-dimensional space, fifth, and so on, and n-dimensional. So some objects we should imagine, just and understand them without graphing. And here, for the multi-valued, in many fixed point theorems, we work with selections. Selections are single-valued, maps attached, associated to multi-valued.
Sir, weakly compatible mapping, a strong compatible mapping, sir.
Yes. What is the difference? How can
Weekly?
Weakly compatible mapping,
Mapping.
and a strong compatible mapping.
Strong compatible mapping.
Yes, sir.
No, actually.
compatible mapping?
Huh?
Compatible mapping and weak compatible mapping.
Okay, I can explain you first what is a compatible mapping. Actually, as I said in the morning, that the commutativity is introduced by initially K. Goebel, as I said, in 1969. But the fame goes to Gaillard Young because of the complete proof after introducing the commutativity maps. So later on what happened, the generalization of the commutativity has come. Sylvester Sesha, as I said, from Napoli, he introduced weakly commutative, and I have shown you the condition also of the weakly commutativity. So this condition, the distance of STXN and TSXN, if this is tending to 0, whenever you choose the sequence xn in X such that Sxn, Txn tends to T for some, this is not for all, for some T in X. This is the compatibility. Okay. So actually what is the ultimate utility of the compatibility? So morning I was trying to explain you each component of the Zung's fixed point theorem. Okay. So in that component what happened? This component, okay, this component is helping you to obtain the first fixed points and later on uniqueness of the fixed points by using the whatever the contraction condition is given. So to proving this, what happened, this is T or Z you can say. So ultimately we are going to get the coincidence point. Bochera is there, he proved one theorem recently means some 15, 16 years over, and he has shown that this condition holds. If you carefully read our paper of Mass Japonica, we have given 3 propositions also, and we used continuity as a pivoting tool of such maps. So this condition, Szn equal to Tz, and ultimately what you need, can I have Stz is equals to Tsz? Here this is a coincident point, this is point of coincidence, and if you have S omega equal to T omega equal to omega, your fixed points are this, your fixed points are not Z. Coincident points are becoming the fixed points in all such cases, if you carefully read the papers. So what they have done is, Zung and Rhodes, they have written once again a paper and published in Indian Journal of Pure and Applied Mathematics. They were talking about the weak compatibility. Okay, what they say, this is compatibility. Okay, they say that if Sz is equals to Tz, and this implies that commutativity holds, then they say that this is weak compatibility. So they are and means you can say the, like we say the and users. So they are talking about the and user part as a weak compatibility. But there are many other compatibilities also. Apart from this, as I mentioned, my condition along with Zung and Cho, what we have done is, we have split like this, Tsxn, Ttxn, this is tending to 0, and we are using AND condition here, and this distance of, Tsxn other way, and Ssxn, this is also tending to 0 under the same condition, this one, whenever xn be a sequence of x such that limit of Sxn and Txn equal to z for some z in x. This is compatibility of type A, we said. It is also later on we realize, after some I think 5 to 10 years later, we realize that because the fixed point theory is rapidly publishing like anything, we realize that even while proving, we don't need both conditions simultaneously. One condition is enough. But for our prepositions we need, whenever we try to say that compatibility of type A implies compatibility, and compatibility implies the compatibility of type A, in such cases we need both conditions. Okay, otherwise one condition is enough. If you presume that T is continuous, see the beauty, T is continuous, then you have this is Tz, and now you see this Tsxn, this converges to Tz. So you are getting fast, but it doesn't mean it is very fast, but you are getting this. So they call in this context as a weak compatibility. So like weak compatibility, they have the weak compatibility of type A also. There are many compatibility defined by many people like R.P. Pant, Professor H.K. Pathak, and there are many South Koreans, and then some Chinese, then Thailand people also. Sylvester Sesha of course did, and after his definition, weak compatibility, he stopped working in the fixed point theory and he shifted to fuzzy. So this is what? Sir? Huh? Yeah, there are many. There are many. I have given a survey also. In 2000 paper, this is published in non-linear analysis. I have given the survey, and as well as you will find a algorithm also. Like he says that he is from the computer science background. So I have always the inclination towards algorithms and programming, etc. Of course, I am not from the computer science background. But I have such ideas in my mind always. So I always do such things in most of the cases. So if you refer that paper, so you will understand that such kind of things are given there, and you will find this kind of table. This kind of, today I am not getting much time, so I could not put the JPG file. And Professor Birende is given some prediction. This is my prediction. This is my prediction regarding the where the mapping lies. And as on today, it is working in the same manner. I can say that. So if you have, yeah, you can take this paper. You can take the whole paper. This is in non-linear.
I was using some of this.
Yes. Yeah. This is almost a 50 years, 50 years of reviews work. 6 months reviews in Banaras Hindu University when I was RA. So any other, is it okay? Yeah, okay, thank you. Any other question?
Hello. My question is Professor Vasily Brinde. Sir. Just out of curiosity, I noticed in your lecture that you remember a lot of mathematician names, his stories. I mean, how do you remember all of this? And second question, how much time one should take to read a paper? I mean,
Which one?
research paper, any research paper.
How long?
In general, how much time one should take?
I explain you how much time I can afford for research. So it's about 10-15% of my time. Well, sometimes I write a paper, a quarter of it now, then I leave it for half a year. Because of other activities, I take it back. Sometimes I forgot. I really forget about them. If I will show my computer, I have some tens of drafts. Some of them are 10 years old. So I just started, I abandoned because of missing time. So it depends. When I find something very interesting, so it happened to me with this couplet, fixed points. I wrote in 1 month 3 or 4 papers, really. But I was in the break between the 2 semesters, and I stayed 16 hours in front of my laptop, and after 2 or 3 weeks, I went to doctor, and because I had some problems, and he said, it's not from heart. Is from sitting and working to the laptop. So I did this foolishly. So I stayed 16 hours per day. I worked in front of the computer. So this is not healthy. I do not recommend. But it happens sometimes when the topic is very hot. So this you feel, also when I discovered this enriching technique, I was very excited. But after 2 or 3 papers, I said, it's enough. I leave others to work, and so it's a kind of saturation. So you cannot, but I know people who are producing. One of my colleagues in my university, he's really incredible. I don't understand how is he doing, but he's writing 30, he has just 2 or 3 collaborators, and he's mainly writing these papers, 30, 35 papers per year. I don't understand. So I can produce 5. So it's not a matter of, it's not a rule. So it depends on the time. Usually I work during the summer when I have no classes, when I spend some time with my family. Now I have grandchildren which are who grow enough to leave me to work, but some of them are not, so I can afford to work on summer. So during breaks. And the best way I work is leaving for 1 or 2 weeks my office to some university, and there I can work. At home is very difficult. That's the recipe to write a paper. But first you should stay and read and think many hours. So sometimes during sleep you can have a good idea, and that happens. Sometimes I'm telling myself, oh, how stupid I was 10 years ago. I did not realize this. And the final comment is that we have in Romania he died many years ago, a very famous writer. And he wrote a book about his childhood and the period when he started to write first novel. And he said, I realized that all the time I said of myself, wow, what a stupid guy I was yesterday. And I did this all my life. So it happens. This is, sometimes we do not catch an idea. And I explain some such instances. Sometimes we cannot catch an idea. Some people are catching immediately, some others not. So it depends on how committed are we to work. In my opinion, commitment is very important, to be devoted to this work and to work hardly and to be attached to this work. Are you satisfied? Okay.
Let me add one more thing. What he is asking is, so actually there is no hard and fast rule. Please be comfortable. There is no hard and fast rule that how much time you need. I told you, there is only one paper, and I was talking with Professor Veermani. For the past 25 years I am working, and I have no answer. 25 years. Whenever I get time, I work, but I don't get answer. There is one more incident, but this is true that a researcher conceives some idea, even in your subconscious mind, it is working. And if the problem is unsolved, it is working more. If problem is solved, it is not working more. I can give an example. If you can check in Hezitepe General, one paper accepted. For that, I can say that I went to home from my department. This is around 2008. And nobody is at my home. My family was staying in Hyderabad. I had good coffee and tea. I sat around 5:36 in the evening. I finished off my draft at 11 o'clock at night, handwritten draft. Morning I wake up around 4 o'clock. I start typing the draft. Again by 9:30 or 10 o'clock I finished. Communicated in the afternoon. Within 3 months published, without revision. Sometimes happen, we don't know. But this is not that one day you can write a paper. Actually, this conceived long back. It is somewhere in the conscious mind, and on that day suddenly that evolve and says that you do this. Second thing, regarding the remembrance of the mathematicians, only one thing I can say, not only mathematics, any subject. No need to, at least in 24 hours, morning also I said, in 24 hours time, you have 1 hour time. That you have to identify. What is that 1 hour time? And that 1 hour time, if you pay properly, what mathematician? Anyone can, possible. Date and volume number, page numbers, that is possible. This is all because the hard tradition, hard